Use the first derivative to find intervals of increasing and decreasing for the function f of x equals 5x to the 1/3 minus x to the 5/3 power. All right, so it tells us right away to find the first derivative, right? Let's go ahead and do that, f prime of x. In this case, we can use the power rule. I'll bring down that 1/3, multiply that by the coefficient that's already there, so that's 5/3. X to the, and 1/3 minus 1 gives us negative 2/3. Here, same thing, I'll bring down the 5/3. That just becomes 5/3 in front, and then 5/3 minus 1, which gives me 2/3. And here we go, right? This is our first derivative. How do you find critical numbers? Remember, critical number is anywhere where the first derivative is equal to 0 or undefined. Okay, so if we rewrite it like this, right, this x to the 2/3 goes on the denominator because that's a negative power. And we have something like this, right? So we want to set this equal to 0 and solve. But we also notice here that x is in the denominator, right? So 0 is a critical value, okay? And what about the other ones? Well, we just have to solve this guy. There's a couple ways to do this, but what I'm going to do is I'm going to add this term to the right side. That becomes a positive over 3. I'm going to cross multiply these. Okay, 5 times 3 is equal to 15. And when I cross multiply these together, I get 15x to the 2/3, x to the 2/3 times x to the 2/3. We've got to add those together, right? 2/3 plus 2/3, which gives us 4/3. Okay. Divide both sides by 15. So I get 1, which is equal to x to the 4/3 power. Okay. And this, if you rewrite it, right, it's the cube root of x to the 4th power. And there are two answers here, right? X is equal to -1 and +1. Okay, so that means we have 3 critical values here, right? We got -1, 0, and 1 here. Okay, so we are broken down into 4 intervals, right? -infinity to -1, -1 to 0, 0 to 1, and 1 to infinity. So now we just got to plug in a test point, right? Plug in a test point in each interval, plug it in, okay, and then see what your sign is. Are you positive or negative, right? So -2 we'll plug in, -1/2 maybe, right? +1/2, and something like +2. Now, remember, we got to plug these into the first derivative, right? Not into the original function, right? We're finding where the first derivative is positive or negative. All right, so I did use a calculator for this. When I plugged in the -2 in here, right? F prime of -2, that got me something like -1.6 something, right? The number doesn't matter. What matters, though, is that this interval is negative. Okay? -1 to 0, when I plugged in f prime of -1/2, I got something like positive 1.6 something or other, right? But this interval is positive, so same thing, f prime of +1/2 and f prime of 2, right? This one gave me a negative result, and this one gave me this one gave me a positive result. Sorry, I mixed those up. All right, this one gave me a negative result. Okay, so this interval was positive, this interval was negative. So what does that mean? Right, it means that my function is increasing. Okay, so this function is increasing wherever the first derivative is positive, right? Notice I don't put from -1 to 1. Okay, it's -1 to 0, union 0 to 1. Right? Similarly, decreasing, okay, -infinity to -1, union 1 to infinity. What's happening at 0? Okay, if you take a look at the graph, I think there's going to be a vertical tangent line, right? So all because it's increasing here and increasing here, that does not mean you can just say from -1 to 1. Okay, and on another note, right, there's going to be a minimum here. Okay? There's going to be a local minimum here. We're changing from decreasing to increasing, right? We're changing from increasing to decreasing, right? There's a maximum here, but there is no local extrema here because we're just going from increasing to increasing here.